Hello everyone, welcome back to the channel. Today we will start a new topic, process management in operating system. Every operating system is designated to manage the resources of the computer efficiently, such as CPU, memory, input and output devices or storage. Among those, one of the most critical responsibility of the OS is to manage the processes, the running instances of the program. The process management ensures that each active program gets fair access to the CPU, execute correctly, and doesn't interfere with any other processes. In simple words, if the parts of the operating system is decided what runs and when to runs and how long it runs. Understanding the process management is a critical because it forms the backbone of the system, multitasking, responsiveness, and a performance. So the it gives you like this. So and again, what is a process? A process is a program in execution, while a program is a passive collection of instructions stored on a disk. The process is an active entity loaded into the memory, designed resources, and managed by the operating system. For example, when you open the Chrome in OS, it creates a process that includes our program code like instructions, the current activities, that's program counter and register what is the status of the current activities, the allocation memory that your whatever the memory it is allocated, and the open files and IO devices. If you open a multiple browser window, each window may run as a separate process or a thread in a group. So what is process states? There are different types of state, how this process will work. A process doesn't stay in a one condition. It moves between the several steps depending on what you are doing or what process it is running or process groups is running. The main state of the process is a new, ready, running. Wait and terminate. So the new means that the process is being created, when new process is being created or group of the process is created. Ready means the process is waiting to be assigned to the CPU. The running is for the running instructions are being executed by the CPU. The waiting or blocked is a process where is waiting for the some of the events like IO completion, and terminated the process is finished their executions. This model helps the OS to keep a track of what every process is currently doing, and it decide what is happened with the next step. So the next step is like a process control block. Its short formly we can call it as a PCB. The OS maintains the special data called the process control block for each process. It acts like an ID card that containing all the details about that process. The contents of this PCB is a process ID, which is used with a unique identifier. It helps you identify the unique number of each process. Then the process state like a new, ready, running, etc. The program counter like a address of the next instruction that to be executed. Just for the CPU register, it is resume the process correctly. Memory management information like a base and limit register, page tables, accounting information like a CPU usage, execution time, priority, IO status, list of the open files and devices. Whenever the process is suspended or resumed, always refer to the PCB to restore or save data for save its data. That ensures that the process is isolation, meaning the process cannot affect the one another memory or a data. So the here some of the process life cycles a creation, execution, waiting, ready queue, and termination. Just like we saw here in the process state, we have five state in each process, like new, ready, running, waiting, and terminated. Uh, the creation, the OS loads the program into the memory, assign PID. Just now we saw the PID. That is PID, process ID. and it allocates the resources. Execution: the CPU executes its instruction until it's finished or interrupted. For the waiting, if you need the data from the disk or user input, it goes into the waiting state. A ready queue, once the waiting is event is completed, uh, it returns to the ready queue. The termination: after completion, OS deallocate resources and improves PCB. Here some other process life cycles like a queue uh, uh, queue used for the process management, like a job queue, ready queue, or device queue. In a job queue, all the processes in the system. In a ready queue, processes are waiting for the CPU to allocate some processing time. Uh, for a device queue, it processes are waiting for the IO devices. What are the type of the schedulers? Schedulers are the algorithms or the models that determines how processes are selected for the execution. There are three types of schedulers in the most of the operating system, like a long-term scheduler, short-term scheduler, or medium-term scheduler. For the long-term scheduler, it decides which processes are admitted into the system. It controls the degree of a multi-programming, like number of processes in a memory. It runs on a less frequently. For a short-term schedulers, it selects which ready process runs next on a CPU. It executes very frequently in in milliseconds. The code of the scheduling algorithms in a medium-term scheduler used for suspending and resuming the processes. It is temporarily removes the processes from the memory to manage the load. Together, these schedulers maintain the smooth multitasking without overloading the CPU or the memory. What is the process life cycles? Just like we saw the process life cycle. The next one is inter-process communication, IPC. The processes often needs to communicate and store the data. The OS provide a mechanism called inter-process communication, that is IPC. In the IPC mechanism, it contains a pipe, message queue, shared memory, semaphore, and a socket. For the pipe, it is unidirectional data channels for communication. Message queues, like a queue structure for sending and receiving the messages. Shared memory, like a multiple processes access the common memory region. Semaphore, used for the synchronization and preventing the race conditions. For the sockets, it allows the communication over the networks. IPC enables the cooperation between the processes. For example, when a web server, multiple workers process may share the data through shared memory or message queues. For the conclusion of this process management part one, process management is a foundation of any of the modern system. Each process gets a fair CPU time, system resources are used efficiently, conflicts between the processes are minimized. From the moment you power on your devices to give the time to shut down, process management is silently work behind the scene. It operates millions of operations per second, where its scheduling tasks, handling the threads, managing the memory, or ensuring the synchronization. Process management enables the seamless multitasking we rely on every day. It assurance the efficiency and reliability of any computing system depends largely on how the effectively it manages the process.